In this video, I'm going to show how to disassemble and service the automated needle valve. I will be doing this using our 5 Tesla test system in a rectangular cryostat. The size and shape of the cryostat can vary, but the construction of the needle valve is always the same, so these instructions will apply as well. We start with the system running circulation in the VTI, and as you can see, the automated system is controlling the pressure at 8 millibar and everything is stable. Before we can proceed with the service, we need to disconnect the controller and allow the actuator to cool down, which usually takes about 15 minutes. So I'm just reaching out to the cable and I pull the plug and remove the connector. Now we leave the system in this state for a while, and you can see as the control stopped operating, the pressure in the VTI is rising. So I'll move over and stop the scroll pump. We will need a gas cylinder with a regulator. Now I'm opening the pressure. The regulator is set to about 50 or 100 millibar above atmospheric. So when I open the flow of gas, I can feel a small stream coming off the nozzle. I have a KF16 fitting at the end of the tube. Now it allows the gas to flow for some time, and this way it expels the air and purges the tube. While the gas is flowing, I connect the fitting to the back connector of the scroll pump, like this. Now we need to check the position of all the 3 valves on the pump and up assembly, and they all need to be open. So I'm opening valve number 1. I'm also opening the bypass valve, like that. And the valve on top of the dump is open as it was while the system is running. Now the gas, pressurized gas from the cylinder, comes to this manifold, and the pressure goes into the exhaust part of the VTI as well as into the dump, and hence to the inlet pump part of the VTI. This way, when we remove the needle, both sections of the VTI will be pressurized and the gas will be flowing into the needle valve space from both sides, bringing out any dust or debris which might be in the circuit. While we were connecting the gas cylinder, the actuator had enough time to cool down. You remember the cable was unplugged, so there was no heater power, and I can feel that it just feels lukewarm to the touch. It is cooler than it was during operation. Now I can hold the lower part of the plastic assembly with one hand and unscrew the top part with the other hand. And I do it nice and gently. And we'll remove the top part to expose the wax cell of the actuator. There are some electronic components and sensors in this part, and we will not need it for the further work, so just put it to one side. Next, I will remove the lower part of the actuator, which is directly connected to the needle valve tube. The stainless steel component at the bottom part of this assembly makes a vacuum seal, so it's important that when we reassemble it, it is done up tight. I use a spanner to undo it, and then unscrew it completely by hand, and I will need to pull the tube gently and strictly vertically so not to damage the tube. So this is the tube of the needle valve. There is gas coming from this hole, and to stop the gas escaping we will block the hole in a minute. We have detached the tube from the actuator, and first we need to check that it is straight. And the most important part of the assembly is the black tip at the end of the tube, we need to check that it is nice and smooth and round and doesn't have any scratches or embedded dirt. This is the microscope image of the tip, and you can see that this tip is in a fairly good condition. It doesn't have anything which would prevent it from closing correctly. No scratches, no scuffs. It's nice and round and shiny where it makes contact with the seat of the valve. Before we start the reassembly, we need to clean the tube and the tip to make sure that they're free of grease and any residual moisture. We use acetone and soft tissue paper to do so. Of course, it needs to be done with reasonable care to make sure that the tube doesn't get bent. Now we are back at the system, and you see I used the top of the actuator to block the escape of helium gas, so we didn't lose the entire content of the helium cylinder. I can remove it now. Inspect the O-ring. It needs to be clean and lightly greased with no dust on it, no dirt. Now we can insert the needle tube. It goes in lightly, just under its own weight. There is a nut on the tube, as you saw, and the nut to be sitting at the right position. It needs to be approximately 4 millimeters below the stop flange where the O-ring sits, and we can check that using slide calipers. You can measure it like that, and in this case it comes out to be 4.7 millimeters. In principle we could adjust the position of the nut, but if we are within about a millimeter from 4, everything will work. Now I lift the tube a little bit, hold on to the nut so it doesn't move, and attach the top of the actuator. At this stage everything needs to be just finger tight. Okay? Now the actuator moves down, engages with the thread, and again I do screw it on finger tight until I feel a little bit of resistance. At this point I stop. I want to check that the tip of the valve is not accidentally already pressed to the seat. I need to check that there is a gap under the tip, and to do so I use a suitably large component that can press onto the actuator. I can press by hand and I can feel it moves by about a few millimeters. This is the central part of the assembly, which is directly connected to the tube, and it moves up and down under my force and returns by the force of the spring. Because I can feel that there is gap, I can proceed and tighten the stainless steel component and make it vacuum tight. I double check again that the valve can move using my hand pressure and that plastic spacer. I can feel that there is about 2 millimeter gap under the tip of the valve. Now I reassemble the top part of the actuator like that. There is no vacuum here, so all this needs to be just hand tight, and we can now plug the heater connector back in. This completes the service of the needle. Now we should disconnect the gas cylinder. Most likely the gas inside the dump is contaminated with air. This usually follows if the needle is not working. So the next step would be to connect a pump and evacuate the dump and the entire VTI circuit. After that, refill the dump with pure helium and restart the circulation, and everything should work.